Hey everyone, welcome to this video. So today in this video we're going to be solving the book allocation problem. It's a very famous problem. It's a Google interview question. It's a hard level problem. So let's start. We are given number of pages in n different books and m students. The books are arranged in ascending order of number of pages. Okay. So the first hint is that the array is ascending order array, which means that it is sorted. Therefore, we can, use binary search here. It should strike our mind to use binary search. The next thing is that every student is assigned to read some consecutive books. Whenever we have to divide the elements of the array, in some consecutive chunks, or we have to assign them to particular X, Y, Z, whatever, then it's a pattern problem. It's good if we use binary search there. It reduces our, time complexity. The task is to assign books in such a way that the maximum number of pages assigned to a student is minimum. Okay, so what are they trying to say here is that, okay, let me show you on the whiteboard.
Yeah, folks. So what they're trying to say is that, for example, let's say we have an array of 3 elements, 2, 10 and 8. And I have to divide these 3 books among 2 students, right? Now they're saying that we have to assign the books in such a way that the maximum number of pages assigned to a student is minimum. Okay, so for example, if there were 2 cases, how can I divide these how can I divide these 3 books among these 2 kids? Right, let's see. One thing I can do is I can give these 2 books to child 1 and this to the other child. Or what I can do is I can give this one book to child 1 and then these 2 books to the other child. Okay, so in this case, child 1 is reading 12 pages and child 2 is reading 8 pages. In the second case, child 1 is reading 2 pages and child 2 is reading 18 pages. Now, where is the maximum number of pages read by a student minimum? In which case, the student which is reading more pages is least. You getting my point? It's this one, right? You can see clearly it's this one. Okay, so they're trying to ask that we have to assign the books in such a way that in whatever combination we are making, the child who is reading the most number of pages has to be the least number of pages as compared to the other combinations. Okay, so let's go ahead. For example, our array is 12, 34, 67 and 90, right? And I have to distribute these 4 books in 2 students. Okay, now what's my approach gonna be? See, it's clear that I have to apply binary search, and whenever we apply binary search we have to choose a range, right? So in this problem, if you think deeply, what is the minimum number of pages a child can read? The minimum number of pages can be, if for let's say I had 4 kids, right? Then this one book was given to one child, this book was given to the other, this one to the third, and this one to the fourth. Therefore, we can see that if we take the least, if we assign each book to an individual child, then the least amount of pages, then the least amount of pages read by a child is going to be 90, right? Now I can't further divide it. I can't divide these books in 5 children, as I can't give half book to a child. I have to give one complete book. Therefore I can't go less than that. Therefore my required answer, that is the maximum number of pages assigned to a student, the minimum possible value for that is 90. So my lower end, as in my start, I will take 90. And what can be the maximum number of pages read by a child? In what condition can I get that? Let's say we had only one child. Then what would have been the case? I would have to give all these books to that single only child, right? So therefore, in that case, what would have been my total number of pages? My total number of pages would have been 203, the sum of all these pages, right? Oh, so now that I know my range, that my range is going to be from 90 to 203, I have to find a middle value. That's what I do in binary search, find a middle value. So what's the middle value here? The middle value here is 293 upon 2, that is 146. Okay, that is 146. So I have to check in this range. So now what I have to check is that if I assign the books in such a way that the maximum number of pages assigned to a child is 146, if that is possible, then that's a possible answer. Okay, let me show you what I'm saying. If I give the first child 12 pages, done. Then I give him the second book as well. Now he has total 46 pages to read. Now if I give him the third book as well, 46 plus 67. Now he has 113 pages to read. Now if I try to give him the fourth book as well, he will have more than 146 pages. Therefore I stop here. These many books I give to child number 1. And now if I try to give this book to a second child, I can do that as it is less than 146. And my combination is complete. Okay, so 146 can be a possible answer, right? If I encounter a condition when my middle element can be a possible answer, then I move my end to mid minus 1, right? I move my end to mid minus 1 to shorten the range and check further. Okay, now my end comes here. So now my new range is, folks, 90 to 145. My new range is 90 to 145. Okay, now what's the mid here? Now the mid here is 117. Okay folks, now I have to check the same above checks for 117. Okay, let's move ahead. Now if let's change the color. Yeah, now if I give the first book to the first child, he will have 12 pages. Okay, if I try to give him second book, he will have 46 pages. Okay, it is less than 117. I can do that. If I go further, what am I seeing? The first child will have 113 pages. Okay, that's still less than 117. I can do that. If I try to give him the fourth book as well, no, I can't do that as it will exceed 117. Therefore, these three books can go to child 1 and this book goes to child 2. Now 117 is also a possible answer and it is less than 146. Therefore my current answer is 117. Okay, now as I told earlier also that I have found my possible answer, so I'll move my end to mid minus 1. Right folks, I found a possible answer, so I'll move my end to mid minus 1. So now my end is gonna be what? 116. So the new range is 90 to 116. Right. So what's the new mid? The new mid is 103. Now if I try to do that, these books can go 46. If I try to give him the third book, no, I can't do that. Right. So first child has these two books. Okay. If I try to give the second child this book, yes, I can do that as this is less than 67. But if I try to give him the fourth book as well, I can't do that. Why? Because this sum exceeds 103. Therefore, I have to only give this book to this second student. But now this book remains. Now what to do? I don't have 3 children. I have only 2 child. So I can't give this book. This book is left alone. Therefore, what will happen is that this is not a possible answer. I will have to look for more number of pages. Therefore, if I want to look for more number of pages, therefore I will move my start to mid plus 1. Okay. To look for the potential answer, I'll move my start to mid plus 1. So now my range will become 104 to 116. Now my new range is 104 to 116. What's the mid now? The mid is 110. Right. Now if I try to, assign these children the books such that the maximum number of pages read by one child is 110, as we have already checked so far that we can't do that because this will have 46 sum, and if I try to give this child this book as well, it will exceed as it will become 113. Therefore I can't do that. So the first child only has these 2 books. If I want to give, now I call upon second child. I give him this book, third book. He has 67 pages. Now if I want to give him the fourth book as well, I can't do that. Therefore now also I need more number of pages. as like my fourth book is left again. You're getting it? Now we have practiced it a lot. Now by now you should get what I'm saying and doing here. Okay, so now I have to increase, look for more number of pages. Therefore, I increase my range. In order to increase my range, I go to 111 mid plus 1, right? So now my range is 111 to 116. Now the mid here is 113. Okay, so now let's check for 113. If I try to give this child to if I try to give this book to child 1, I can do that. He has 12 pages. If I give now this book also, he has 34 pages. Okay, I can do that. Now if I give this book also, now he has 113 pages to read, right? Okay, we can do that. If I try to give this book as well, no, it will exceed 113, so I can't do that. So now I have to give this book to the second child. He has to read 90 pages. Okay, that's done. No more books left. Therefore, this is a possible answer. 113 is also a possible answer. So folks, as we have encountered a possible answer, so I have to decrease my range. I have to, bring my end to mid minus 1, right? So okay, let's do that. But I can see that we won't be able to that 113 is an answer, but okay, let's continue. So we'll bring our end to mid minus 1. So our range is now 111 to 112. Okay, the mid here is 111, right? Now if I try to give this book to child 1, okay, I can give this book. Okay, I can give this book. No, I can't. As sum is 113, we have seen earlier. I can't give this book to child 1. Okay, let's bring child 2. Okay, he can get this book. Okay, fine, given. Can I give this book to him? No, I can't. As the sum increases, therefore I have to increase my number of pages. Okay, so now my start goes to my start goes to mid plus 1. Therefore my start goes to 112. Okay, so now my range is 112 to 112. Mid is 112. As we have seen, so far we have seen it many times that 112 will not be satisfied. Why? Because this sum is becoming 113, so we can't give this to one child, and this, if we give this to child 1, then this is more than 113, 112, sorry, so we can't do that. Therefore 112 is also false, right? Therefore we move our start to mid plus 1, right? Mid was 112 here. I move my start to mid plus 1, that is 113, and for 113 we have already checked that we are able to get the answer. So therefore, by these many permutations and combinations, after going through so much trouble, we have finally found our answer, that is 113. So 113 is our required answer. I explained it very clearly, folks. This was a very big example, so it had a lot of cases. So I guess that by now you must have understood my concept, what I was trying to explain you. But if not so, then no worries, you can anyways watch the video again and again till you get the concept and get the idea behind it. It's very simple. Once you get it, it will be very easy for you, and this is a very good problem. And so I suggest that you go ahead and try to code it first. If it's if you can't code it, then no worries, you can come back and watch the video and watch the solution.
Yeah. So okay folks, I hope you must have coded the solution, but if not so, then no worries, you can check my code and see your wherever you are mistaken. Right, so what I've done here is this is the array that we took in the example. M is equal to 2, and I have made a function min pages, right? So I have initialized a start to the minimum element of the array, right? And I have initialized my end to the sum of all the elements of the array. My result is currently 0. Okay, now this is my binary loop, right? My start is equal to end, mid is this. If now this is the function which is important here, is feasible. Let's first see this function. Is feasible, takes the array, takes the number of students, and takes the result value, that is the mid value, right? And currently I have initialized my students to 1 because there can't be no 0 students, right? Because in any scenario, there must be one student who will read all the books. Therefore, students is always going to be starting with 1 and my sum is 0. Okay, so for this entire length of the array, this for loop I've taken, if my sum, that is 0 currently, plus pages of I, that is the current pages of the current book, right? If that sum is is greater than result, sorry. If that sum is greater than the result, that is the middle element, then we increase our student, that is we call the next student, and our sum becomes the current pages in the current book. Okay, so let me explain you more clearly. For example, if in our last scenario that the middle element was 113, right? So if I give this to first child, it's okay, we can give. If I give second one also, okay, we can give. It becomes 46. If I give this one also, okay, we can give. It becomes 113, right? Till now, this is okay. Till now, this is condition is not passing, right? So we are moving on. We are just adding like this. Else we are just adding sum plus is equal to pages of I. Till now, this condition has not passed, so we are just following this. Okay, but now if I try to give this book also, then this condition passes. Then this if condition passes. So now what we're doing? We're doing student plus plus, that is the student is increased to 2 and the sum of pages, that is the sum becomes pages of I. The sum now becomes 90. Right? Got it? Okay. And then we're returning. This is the way of returning here. This statement means that if this is true, then return, otherwise don't return. Okay. So this function is clear, I hope. And then if then we come back to this function, and then if the result is mid, if this is feasible, right? And if the as we discussed that if I got a possible answer from this from this function, if I get a possible answer that yes, this can be a possible answer, then I bring my end to mid minus 1. Otherwise I take my start to mid plus 1, and then I simply return the result in the end. That is the result, that is the answer. So let's run it once and let's see. 113. That's the answer we got, right? So okay folks, I hope that this question must be clear to you, and you are you are thorough with the concept. And that's it for this video. Keep watching, keep supporting. If you enjoyed this video, please press the like button, and also don't forget to share this with your friends who are learning DSA and want to master it. And keep supporting, keep sharing. Also, I have my community #Inklude. You can join the Discord server, and the forms are out. You can apply for mentor roles, you can apply for student roles. We also have campus ambassadors, we have guest speakers, we have many such things lined up. So you can feel free to join us. And that's it. Bye guys, take care. See ya, have a good day.